Right, so let's have a look at absolute value. The formal definition of absolute value is this. Either you get the answer A if A is greater than or equal to 0, or you'll get the answer negative A if A is less than 0. Basically, it's a distance. So how far away from 0 is it? So you imagine plotting the number on the number line. How far away is it? So magnitude is all we're interested in. Direction, as in, is it on the positive side, is it on the negative side? We're not interested in. So some different results when we're manipulating absolute values. First one, absolute value of minus x is the same as the absolute value of x. And absolute value of x minus y will give you the same answer as the absolute value of y minus x. When we multiply absolute values together, you have a choice. You can multiply them together first, then find the absolute value, or find the absolute value of each individual number, then multiply them. Same with division. Doesn't matter which way around you go. Absolute value of x squared is x squared. Here's the interesting one though. The square root of x squared is the absolute value of x. Simple one to start off with. Absolute value of negative 5, well, how far away is it from 0? Well, it's 5. Absolute value sign is a grouping symbol. So just normal order of operations. You do what's inside the grouping symbol first. So 6 minus 8 minus 2 is negative 4. So we get 4. Again, you do what's inside the absolute value symbols first. So 6 3 is 18 minus 20, negative 2. Absolute value of negative 2 though would be positive 2. 7 minus 2 is 5. 3 times the absolute value. So 3 6s, 18. It's all very basic stuff. But here's the question. The square root of x squared if x is less than 0. And the answer is negative x. The square root of x squared if x is less than 0. So we've actually ended up with a negative number. Or have we? Anyone care to offer up an explanation of how we could end up with a negative for the square root? That's it. Whilst it's saying negative x, it's not a negative number because we specified x was negative, and a negative times a negative would give you a positive. So it looks like we ended up with a negative, but we didn't. All right, the graph of an absolute value. So y equals the absolute value of mx plus b. So a straight line. Whatever is below the x-axis is reflected above, because you can't get negative answers. So y equals absolute value of x would be the most basic one, and we end up with that classic V shape. We usually plot some points on it to give it some sense of scale. So I'll plot in 1 1 and minus 1 1. So how do we sketch y equals the absolute value of x plus 2? A couple of ways of thinking about it. I could say I've got the basic curve y equals the absolute value of x, but it's grouped with the x. Remember, absolute value is a grouping symbol. Grouped with the x, so it's a horizontal shift, and we're going left 2 units. So we'd end up there. So there's our graph. That's one way of thinking about it. Or I could say the basic curve is actually the line y equals x plus 2. And we said whatever's below is reflected above. So if we reflect that, we get the same shape. It just depends how you think about it. Y equals absolute value of x plus 2. This time it's grouped with the y. So our basic curve, absolute value of x, but we've shifted it up 2 units. So we end up with that shape. Solving absolute value equations. Now, I suppose it's simple enough to look at this and say, well, x has to be either plus or minus 7. Fair enough. But what if it was an absolute value of x? Absolute value of 2x minus 3 is equal to 7. Again, I could just say it's equal to plus or minus 7, but that's not how we think about it. We go back to the definition. Remember, the formal definition was absolute value of a is either a or negative a. So when I do this one, I say, well, if it's either a or negative a, but in this case, 2x minus 3. So it's either 2x minus 3 or minus 2x minus 3. Go and solve that, so you get x equals 5 for the first one, x equals negative 2 for the second one. Don't just leave it hanging like that. Conclude it with your final answer. So x is negative 2 or x is 5. Yes, that's identical to saying either 2x minus 3 is equal to 7 or 2x minus 3 is negative 7. But if we think about it this way, when we come to inequalities, we're not going to have a problem. But when we get to that, talk a bit more about that. So absolute value of 2x plus 6 is 3x minus 1. So either 2x plus 6 will equal 3x minus 1, or the negative of 2x plus 6. And we go and solve each of those individually. First one we get x equals 7, second one x equals negative 1. Again, don't leave your answers hanging, but by the way, they're not the answers. It's probably a good reason why we don't just leave them hanging like that. Because we've got a problem. Have a look at x equals negative 1. You sub that into the right-hand side, what do you get? Okay, well how is an absolute value going to equal negative 4? It's not possible. So it's not a solution. That one's no good. So the only possibility is x equals 7. Now why does this happen? Because what's happening is we've started off with an equation to solve. Effectively what we're saying is, that's too tricky to solve. So what I'm going to do is solve a different equation that I know will produce the correct answers. But when you do that, sometimes it produces extra answers as well. And that's why you need to be checking your answers. By the way, with an absolute value equation, this situation where one of them is not a solution, it will only ever happen when you've got absolute value equaling and you've got a pro-numeral on the other side. I mean, if it's a constant number, it's never going to happen. So that's when you need to think about, maybe I'll check my solutions. Okay, that'll do us.